Okay, so at this point you should have completed the table for the 45, 45, 90 triangle, and we're going to check your conjecture, which was what is the length of the hypotenuse of a 45, 45, 90 triangle with legs that are n units long? So here I drew an isosceles right triangle, which is 45, 45, 90. You know these angles are 45 because of the base angles theorem. And you should have that the length of the hypotenuse, is the length of the leg multiplied by the square root of 2. Now in problems, you're going to be given the length of one side or the length of the hypotenuse. And you have to go back and forth between the two. Well, the process I want you to follow is if you're given a length of a leg and you're asked to find the length of the hypotenuse, you're just going to multiply the leg by the square root of 2. If you're given the length of the hypotenuse and you're asked to find the length of the two legs, you're just going to take whatever the hypotenuse is and divide by the square root of 2. So I want you to take a moment and write down this process. I'm going to stop and then stop the video and try activity 2. Okay, you should have your data and you should be checking your conjecture. It said what are the lengths of the long leg and the hypotenuse of a 30, 60, 90 triangle with a short leg of n units long. You should know that the short leg goes across from the 30-degree angle because it's the smallest angle. And what you should have discovered is that the hypotenuse is going to be 2 times the short leg, and the long leg is going to be whatever the short leg is times the square root of 3. But as with the 45, 45, 90 triangle, you are going to be given sides of the one or two sides of the triangle and asked to find the third side. When you're solving a 30, 60, 90 triangle, I always want you to consider the short leg, the side across from the 30-degree angle, which we label N, as your home base. Because it's easy to go from your long leg to your short leg and your hypotenuse to your short leg. It's difficult sometimes to go from the hypotenuse to the long leg. But if you come back this way, all you're going to do is divide by 2. If you go this way, you are just going to multiply by 2. If you're going from the short leg to the long leg, you're going to be multiplying by the square root of 3. If you're going from the long leg to the short leg, you're just going to be dividing by the square root of 3. So if you always go back and forth to home base before figuring out the other sides, you'll have a good process to follow. Stop the video here and get this down, and then we're going to solve some problems. Okay, I am talking a little fast because this video has to be under 10 minutes. So I've already labeled the first 3 problems. If you want to stop this and label it, you're welcome to do that before we explain what's going on. Okay, so now I have an isosceles right triangle, and I know that this is a 45, 45, 90 triangle. And I know that if one of the legs is 5, to get from the leg to the hypotenuse, I'm just going to multiply by the square root of 2. So this would be 5 square root of 2, and this would be 5. In the next problem, I have a 30, 60, 90 triangle. I've already labeled it with the ratio of my sides. And I always want to go back to home base. So I'm going to go from the hypotenuse to the short leg, and I have to divide by 2. So I know that this will be 5. Now I can go from the short leg to the long leg by multiplying by the square root of 3, and this would be 5 square root of 3. On this one, I know that this is an isosceles right triangle, so I know that these angles are 45, 45, and 90. They give me the hypotenuse, and I know to go from the hypotenuse to the leg, I'm going to divide by the square root of 2. So I'm just going to take 8 divided by the square root of 2, and if I rationalize the denominator, I get 8 square root of 2 over 2, which is 4 square root of 2. And this is also 4 square root of 2. So if you want to stop the video here and get your notes down, and then we'll start up again when you're ready for the next examples. Okay, so I have the next figures marked, and we're just going to go through the examples. You're welcome to stop this at any time if you need to. Okay, so now I have a 30, 60, 90 triangle, and I have my ratios of the sides marked. And I want to go back to my home base first. So to get from here to here, I'm going to divide by 2. So this would be the square root of 3. And to get from here to here, I multiply by the square root of 3. So the square root of 3 times the square root of 3 equals 3. On this one, I have an isosceles right triangle to go from here to here, because I'm trying to find x. I'm going to work my way right across the figure. To get from here to here, I divide by the square root of 2. So that means this is 9, and this is also 9. Now, I'm going to go to home base. So I'm going to divide by the square root of 3. So 9 divided by the square root of 3. If I rationalize the denominator, sorry I couldn't say that, 9 square root of 3 divided by 3 equals 3 square root of 3. So that's what this side is. Now I can go from here to here, and to go from here to here, I multiply by 2. So 2 times 3 square root of 3 equals 6 square root of 3. So x equals 6 square root of 3. On this one, I have a 30, 60, 90 triangle and a 45, 45, 90 triangle, and they share a side. I'm given 12. To find C, I need to go to home base first. So to find A equals 12 divided by the square root of 3. And I'm going to shorthand this now. That's 4 square root of 3. Okay? So I know A is 4 square root of 3. To go to the hypotenuse, I just multiply that by 2, so this is 8 square root of 3. This is 4 square root of 3 because this is an isosceles right triangle. Now B is to go from here to here, I multiply by the square root of 2. So I have 4 square root of 3 times the square root of 2. So B equals 4 square root of 6. In this diagram here, I have drawn a segment that's perpendicular to this side. If I know this is 6 square root of 3. To go to home base, I'm going to divide by the square root of 3, so this is 6. The whole thing is 21 and this is 6, then y equals 15. And I know if the hypotenuse is 2 times the short leg, so this is 12. In the last example, I'm asked to find the length of a diagonal of a square. I know the diagonal of a square divides a square into 2 isosceles right triangles, which are 45, 45, 90 triangles, and I'm asked to find D. So I need to know the length of the sides. Well, if the perimeter is 20, then the length of the sides is 5. And to get from the leg to the hypotenuse of a 45, 45, 90 triangle, I multiply it by the square root of 2. So D is the length 5 square root of 2. Okay, so that's it for the examples. You should work on Evaluate 7.4. I'm going to download this video on the website, so if you have any questions, you are welcome to watch it again. And I'll see you in next class.